I would like to say good morning to each of you that are joining us this morning for the virtual version of the Pennsylvania Hemp Summit. You're joining us for the session entitled Exploring Emerging Technologies, Research and Product Development Opportunities here at the summit. Just as a general housekeeping measure, please remain muted during the session. Each of our presenters will have a time to present, and then following all of the presentations, we'd ask that you hold your questions. You can utilize the chat feature of Zoom to send in your questions, and hopefully we will have time to address all of those. If for some reason we do run out of time, we will be certain that we follow up afterwards. I would like to introduce myself. My name is Mark Gignac. I'm the executive director of a little institute down in Danville, Virginia called the Institute for Advanced Learning and Research. You put my presentation up on the screen. Taylor, I think I'm going to need you. There we go. Okay, I hope everybody can see that. Maybe one of my fellow panelists can give you a thumbs up if I'm on display. Thank you, Tim. Appreciate that. I'm going to walk you through a little bit about what I do down here in Danville and my involvement in the exciting and emerging hemp industry. As I mentioned, the Institute for Advanced Learning and Research came out of the ground about 16 years ago. We are an area that was heavily hit by the move of essentially textiles overseas, and of course we also have remain a very heavy ag presence, although much of our agriculture was tobacco, and as you can imagine, tobacco has changed pretty dramatically in the last 10 or 20 years. And so this institution came out of the ground with the mission of driving economic transformation. We do that in a number of ways, from advanced learning, applied research, advanced manufacturing, economic development, and then we're also a conference center. This is just an I think a shot from a drone of our campus. We presently have 4 buildings and a couple of greenhouses, and we're actually getting ready to break ground literally this week on a 5th facility. We are funded primarily by the Commonwealth of Virginia. About 25% of our funding comes from other sources, but we're not a state agency, but we're what's known as a political subdivision. And what that essentially means, it gives us lots of latitude to do things. And for instance, we got involved in the hemp industry. We basically, our board made a decision to move. We really didn't need a lot of state to move in that direction. Just a little bit about Danville, I mentioned. Danville for many years was known as the world's, still in some measure, it was always known as the world's best tobacco market. There was more tobacco bought and sold on warehouse floors here, dating back to 1793, than anywhere else in the North America. We did not roll cigarettes here. That's one distinction. People think of Richmond, Virginia, or North Carolina areas where they actually rolled cigarettes. We did not have companies that rolled cigarettes, but we did. Most of the tobacco was sold. One interesting statistic highlighted in blue that in 2019, the tobacco production dropped 19% in 1 year, if you can imagine. And so that's some of the impact that has put us where we're at. Of course, this slide, I think, applies to everyone. I've titled this Southeast because that's where I'm located. But, there's a reason this hemp industry is attractive. Of course, we have a huge agricultural industry, and I would note that our ag and forestry in our state is still 37% of the state's economy. So it's a big deal. We have lots of underutilized land, lots of agricultural experience, and we have a lot of processing experience. And of course, at the end of the day, we're hoping to provide financial opportunities. One of the things we pivoted into just a few short years ago was the hemp industry. I actually had started following hemp as a curious citizen before I ever worked in this institution, and it's kind of ironic that I'm here now. And so, under our applied research department, we actually started looking at hemp. And so today we're very heavily involved in just a short period of time. We're very heavily involved in hemp in the Commonwealth of Virginia. Most people consider us the leader in this industry. And we have a number of activities that I'm just going to run through very briefly, but we do have a hemp testing lab. We have had a analytical chemistry lab for a dozen years. So testing of agricultural products is not new for us. Testing pesticides is not new. But we did pivot and we're able to really upgrade our lab to the latest and greatest equipment. And we do lots of testing for both farmers, extractors, processors. I think this season we'll test for about 150 growers from a multi-state region. We also are a research institution, so we're not just simply a test lab. We, have a long history of agricultural research, and so that ties in nicely with all the opportunities that are, or the research that is needed for usage of this crop that has many uses. Um, excuse me. One of the things, first actually, our first venture into this is we started an event called the Industrial Hemp Summit. That was really our first entrance into the hemp industry. Last year was our third summit. We sell out every year. It sold out at 400 people, and we had people from 25 states here last year. That is in doubt this February, and we haven't made an announcement, but that's probably in doubt. We also had a grower expo in January. So we have three major events. Our grower expo, very inexpensive to attend. It's geared to farmers. Last year was our first year. That has been canceled, I'm afraid, due to COVID this year. In March of this year, of next year, we actually have a hemp legal summit. There are many legal issues surrounding this crop and different agencies involved. And of course, states like Virginia, where you have medical marijuana is now legal. So there's a lot of legal things. This event will most likely be virtual. It's doubtful that by March we could hold a safe event. And then finally, we do lots of smaller programs. We call them lunch and learns, where we invite the community in and feed them. It's just free events to expose people to knowledge. We've been doing this for many years across lots of different curriculums, but of course, the hemp ones seem to be always very widely attended. And then with our testing, we actually put out a series of videos to help clarify some of the issues with testing, whether it's for farmers or consumers or other test labs. And we continue to see that energy expand. And in fact, one of my latest venture that we're involved in is forming a Southeast lab association. There are still a lot of issues with discrepancies between labs because there are not standards. And our goal is to work with others to develop standards. And because of our position as this quasi state entity, everything we develop will be transparent and we will share with the wider community. And then finally, the last thing I'll mention, this kind of ties in a little bit to one of our other speakers. The Institute has the largest collection of beneficial bacteria on the planet. We have over 2,000 fully characterized bacteria that we've been using with a variety of crops, but of course the purpose of this bacteria is to ultimately reduce and or replace fertilizers and pesticides, fight a whole variety of issues that traditionally have been done with chemicals. And so that plays in nicely. So that wraps up just a quick overview of what I do for a living down here in Danville, Virginia. If you're not familiar with the geography, Danville sits literally on the North Carolina border. So we have lots of ties into the agricultural activities going on just below us. And so I'm going to wrap up my comments. Again, we will save be happy to answer questions at the end. I'd like to move into our first panelist, Timothy. and Michael are both with Air Products. And Tim is going to start off his presentation. Michael will join later on. They'll be working off the same slide deck. So, gentlemen, I'm going to turn it over to you, and I'm going to put myself on mute. We'll be prepared to jump in as needed. Thank you so much.
Thank you, Mark. This is Tim Lebrecht. I am happy to speak with you today. I am just going to bring my slides up, so please let me know when you can see.
We can see.
Thank you. Okay, so thank you for the opportunity to speak today. I'm with Air Products. We are a large industrial gas firm located with our corporate headquarters in Allentown, Pennsylvania. So that's as much as I'm going to talk about the company, because we do a lot of different things, but I figured I wanted to start with the question of what is Air Products doing in the hemp industry? Because I think that's a question that a lot of people are asking themselves. What are they doing? And I like to say is, well, we're doing a lot, and we're doing things that we're really bringing know-how and technology from other industries that people may not have thought of. So we're a large company that focuses on a lot of different areas: the chemicals industry, agricultural chemicals, cryogenics, food and beverages, biotechnology, pharmaceuticals, water treatment. All of these things are established industries with established protocols and ways to do business, and things that have been finely tuned and finely honed over the years. And industrial gases play a very significant role in all of those, in helping their quality, their safety, the efficiencies, the profitability really enables so much of that. So what we are at Air Products doing is first looking at, well, what do we have? What have we done in differing industries over the years, and how would they apply to the hemp supply chain? Because it really does apply to many areas within that supply chain, and I'm going to go through that today. And then what are the problems? What issues is this industry having that are similar but different? And then where new technology is needed. And that's where my colleague, Michael Himes, is going to talk a little bit about, hey, what are we developing? So I'm going to talk first about what we're doing. First and foremost, I wanted to start with safety, because at Air Products, nothing is more important than safety. Not profits, not our daily work, not everything. Maintaining a workplace, we believe, a fundamental and moral responsibility. And that's for us in our workplace. And we also really think in that responsible care attitude of how do we help our customers? How do we help those in the industry? And to us, the only acceptable goal is zero accidents and incidents. So we're focused on this daily, and how to bring that know-how to the industry. So specifically, the gases that the hemp growing and processing and handling industries that we're looking at is liquid nitrogen and also carbon dioxide. We do a lot of other things with other gases, whether it be hydrogen or oxygen or argon or various things, but really nitrogen and carbon dioxide are the two that we're focused on. Those are industrial gases known for being inert. Both of those are cold, very cold, and we're going to talk a little bit about that. They require unique storage and handling equipment, and that's where the expertise of a gas company like Air Products comes in. They are very safe when handled correctly, and we also manufacture per GMP standards. So that's very important in both the foods, the pharmaceuticals, and as we know, into the hemp processing world, that will be very important. So I wanted to start with, well, what does cryogenics mean? What does it take to be cryogenic? Short answer is temperatures less than a negative 100 degrees Fahrenheit. And what is a cryogenic application? Well, that's using those cold temperatures, using it for refrigeration, for freezing, for grinding, material handling, heat exchange, various different ways of using that. To quick illustrate, nitrogen, liquid nitrogen is the coldest item that we're talking about today. It's minus 320 degrees Fahrenheit. CO2 is also below negative 100, but only negative 109. So they each have their own niche uses. Where the extreme cold is necessary, liquid nitrogen plays a unique role. I also wanted to highlight, where does nitrogen come from? Well, it comes from the air. We take the air, we separate nitrogen, oxygen, and argon through a means of separation called distillation. And that simply is a means of separation from boiling point. So we take that product and we then take it to our customer site. And as you can see on the right-hand side, typical supply situation for a hemp customer would be a liquid nitrogen tank. If it's used as cold, it would go as liquid product. If it's used as a vapor, we would vaporize it. And then it goes through into their system and can be used in various ways. An item to think here is, I know this industry, the cleanliness and the green scenario is very important. And liquid nitrogen is an extremely pure product made in very environmentally friendly ways that can be extrapolated into your uses. So why consider using gases for your hemp processing? I highlighted a few up front. First, safety. Using safety with inert gases, I've been very familiar and I'm following the industry, so I've spotted a number of hemp manufacturers that use flammable products such as ethanol or butane and things like that, where there are fires and explosions. Safety, using the inert gases and really just pulling the oxygen out of the equation makes a huge difference. Hindering mold and mildew growth, standardization and improved product quality, being able to rapidly cool material to optimize extraction or winterization processes, looking to achieve higher production rates, enable sustained and planned manufacturing, and then overcoming manual processes. How can you take something which we recognize so much in hemp is very manual and start now to industrialize and to allow greater synergies that way? So as we look at those gases, I'm going to focus on the rest of my talk now on the biomass processing, the extraction and purification, and that's more in the oil, both of those in oil. And then lastly, also going down a fiber and seed path, because liquid nitrogen especially can be prevalent there. So one of the main areas that we're looking at is freezing a biomass for preservation. So if you start with the hemp supply chain and you have harvested this material and you're looking to say, okay, what do I do with it now? How do I store this for the longer term to keep it safe? Flash freezing via a fresh line or a tunnel freezer is a great area to do that. It preserves product for the longer term. We've had a number of customers actually take this product, run through our freezer where it freezes at liquid nitrogen temperatures, think instantaneously. And then it goes into longer term cold storage. So it can use CO2. Nitrogen is most common as the refrigerant. I also wanted to highlight, this isn't just a once and done. We've done this a number of times. And I want to show a quick video to illustrate this. If I can get this to go here. I will do this. Try this again. It doesn't want to. See if I can do it this way. Nope. Let me get back to this, and I believe I can do it this way. Here we go.
Did you know industrial gases can help improve the harvesting and processing of industrial hemp? The same Air Products gases that have been used safely and successfully for over 60 years in the food and pharmaceutical industries can also be used by hemp processors to improve the quality and yield of their product. Gases such as ultra-cold liquid nitrogen and related equipment, like our tunnel freezers, can help make your production process more efficient. Flash freezing your harvest prior to storage prevents mold and locks in the plant's rich chemical content. During the grinding process, adding liquid nitrogen to the conveyor can eliminate oil stickiness that causes clogging and subsequent downtime. And when cold extracting, liquid nitrogen can be more efficient removing the desired oils, all resulting in improved quality and yield. Talk to us and work with our application experts to review your process and identify opportunities. We have a state-of-the-art applications lab to test your product, or we can visit your site for field testing. Let's work together to improve your hemp production process. Visit our website for more information.
All right, get back to the presentation here. So as you can see, we've done that. Actually, this year, I illustrate here that a 20-foot tunnel freezer has processed roughly 1,000 to 1,500 pounds per hour. This year, we've actually used a 40-foot tunnel freezer and have processed between 5,000 and 7,000 pounds per hour with a company up in the Pacific Northwest. So that technology is very common in the foods world, and there's a lot of product that goes into here. And so that is think of it as an adjacent or an ancillary area where we can directly move into hemp what we've proven in other industries. Here's a quick example of what this particular tunnel freezer is. It comes in 10-foot sections. You simply add liquid nitrogen to it, and then there is a ventilation system that spreads that temperature throughout. So you load it on one side and the product goes out the other, and it could go into other means of like conveyance, or directly into a super sack, or some various different areas on however it would be stored or utilized in that cold state. As far as preservation of materials goes, a different application is called modified atmosphere packaging. This is where use of nitrogen and or CO2 or a blend of that will extend shelf life and also product integrity. It's a way of putting product into plastic bags and pulling the air out so that the oxidation doesn't take place, and then putting in its place nitrogen, CO2, or that combination. So it's a great way of storing smaller amounts of product for the longer term. As you get into super sacks and that, it's a little more challenging, but possible. As we move into extraction and or purification, first, we're looking at many ethanol uses for extraction or cold temperatures. Important temperature range is that -40 to -80 degrees C. Mechanical chilling is really challenged to get down to a -40, and that has really been really a typical low end. Companies that are looking to do cold ethanol extraction have come to Air Products and said, I would love to get down to -70 or -80 degrees C. I've got 30-minute batches, and I need to have product cooled in that amount of time. We're in the process of developing a system that will do that in a very short process. So I'd look forward to talking to those that would like to get cold in a very short period of time using liquid nitrogen. And another means of doing that is cooling the biomass as it also enters that extraction area. The cryogenic screw conveyor that we've created for a cryogrind product line also cools the biomass and then delivers it into an extraction container or uses, and that can be set at whatever temperature you desire, whether it be -40, -60, -80. So it as the liquid ethanol, if it would be ethanol, we'll say the liquid solvent, and also the biomass enter at the same temperature, your continuity and your consistency in your process are greatly enhanced. Winterization is really an area where we've had the most request for cold temperature, as that is a purification process and is removing the fats and the lipids within the CBD types oils, and is even thought of as more important as a purification means. So those heat exchangers I mentioned will be even more common in that particular area. I did mention safety as a focus. Inerting or blanketing is a very common use in the chemicals industry. My team does sizing of blanketing and nitrogen uses for inert and safe environmental use on a regular basis. Nitrogen does not react, and it really removes the oxygen leg of the fire triangle, so that there really is very little opportunity for that risk to be there. Certainly, we recommend that when using flammable products like ethanol, hexane, butane, or heptane, or even others that we've not talked about. So I'm shifting gears a little bit, and I'm going quite rapidly because I'd like to keep moving. Cryogenic grinding. So we're not grinding our biomass in this circumstance. We're now looking at grinding seeds and also and I think Mike is going to talk about a little bit in grinding of fiber. Specifically seeds, the oil content in hemp seed is very, very high. And it also generates heat when being ground. Using cryogenics and the liquid nitrogen within that really allows that high protein content to be unlocked and to utilize into we can make a protein powder, if you will, by freezing those seeds and then and brittling them to the extent that they can be really handled quite well. It allows, using cryogenics allows consistent particle size and also for mill cooling. Prevents screen buildups. You can see on the right-hand side where the oil has built up on a screen. That just told us that was not cold enough and we needed to take our test down one more notch in cooling. And following that, we were quite successful in getting these seeds ground to a very uniform and powder type consistency. Here you can see what a cryogenic mill looks like, where we're putting product in at the upper left-hand corner. The cooling conveyor is what uses the liquid nitrogen, and we have the ability to control that to a desired temperature. The grinding mill is on the lower right-hand side, and that also would have a thermocouple control if desired, and could also just stand alone from the ability of cooling. So those are some areas where we're using some items historically, where the other industries have been quite common and have reaped benefits. I'd like to introduce my colleague, Michael Himes, who's going to now take you through new developments and areas where our R&D approach is taking place. So Mike, I'm going to keep the slides going, and if you just let me know when to change them, I will do so.
Sounds good, Tim. Thanks. As Tim explained, he went over the existing technologies that we've adapted into the into hemp processing. At our corporate headquarters, we do have two full-scale test labs. One is the food test lab. It's mostly for food freezing, but it does contain different freezing tunnels and temperature chambers in which we can test hemp, test the freezing or how long it takes to freeze that type of hemp. We also have a cryogenic applications lab. In this lab, we also call it our grind lab. Here we have various types of mills, pin mills, hammer mills, turbo mills, and they're all adapted to use cryogenics. We can arrange to test small batches for your evaluation, or as we indicated in the video, we do have equipment that we can transport out to your facility and do a longer term trial. I'm going to talk about two projects that we're working with universities. We're working with the University of Virginia and Thomas Jefferson University, conducting various tests using cryogenics processing of hemp. Next. Tim talked about using the cryogenics for grinding of oily seeds. We're also looking at how can we apply cryogenics to help grind hurd fiber, or even the fiber and hurd together, just to take a dry stalk and grind it into powders. This is a test that we're collaborating with Jefferson University and various other hemp growers. What we're doing is we're injecting liquid nitrogen into the mills, trying to keep a consistent temperature during the grinding of the fiber and hurd. Generates a lot of heat. So the liquid nitrogen cools the cutting chamber, eliminates that unwanted heat, and by doing that, we're able to get more consistent fiber lengths, so a narrower bell curve on the particle analysis. We're also, by cooling the chamber, we're also preventing material from sticking to the blades, to the chamber. So If you have any oil coming in with the fiber herd, or if you want to do a full plant, we can do that, as Tim was saying with the oily seeds. The nitrogen also inerts the chamber, so now we're eliminating the possibility of dust explosions. Okay, next. We're also working with the University of Virginia. We're doing with University of Virginia, we are determining all the benefits of freezing harvested hemp. This is not freeze drying, it's freezing, as Tim explained. We do know that we can mitigate the mold from hemp sitting around. We can flash freeze the hemp very quickly, and then you can get it off to a storage facility to prevent the growth of mold. But there might be other benefits. So we're comparing the oil yield between dried and frozen hemp. Does the drying process eliminate some of the oil? Does it destroy some of the oil? So therefore, by freezing, we can increase your oil yield. Does it also preserve any of the minor cannabinoids that may be present in your hemp, or the terpenes? Terpenes are very volatile when exposed to heat. By freezing, we're going to lock those terpenes in and then extract them later. The other thing we're looking at is, can we prevent CBG-A, CBG? So can we prevent that from degradation due to heat? We're also looking at what are the benefits of extracting at the colder ethanols. Do we eliminate any impurities? Chlorophyll, can you extract without drying? Can you extract a frozen hemp directly from harvest that's not dried? And will that help eliminate the water during the extraction process to make it easier to extract the oil? I'll turn it back over to Tim, and he will wrap it up, and then we'll take questions at the end of all the presentations.
Thank you there, Michael. I appreciate that. Yes, we are wrapping this up. As you can see, that there's a lot of things that we are in the middle of and look forward to over the next year or two, to really being able to provide both publications, white papers, and discussions, and welcome any interaction with those in this industry, especially here in Pennsylvania, as both Mike and I are located in Pennsylvania. It would be easy to have those conversations. So as Air Products, we are continuing to apply our knowledge from other industries toward hemp. How can we help solve issues using know-how that exists? And then we're leveraging partnerships with universities and other expertise to advance research, to again, solve issues. So how do we apply learnings in the field? How to grow this industry? Those are our biggest challenges. And we want to make sure that as this industry evolves, and both food protocols and pharmaceutical protocols become really a requirement, how we can use our know-how, and having done this for years, to really ensure safety, and then to enable quality and efficiency, and ultimately greater profitability to those in this industry. So with that, I want to say thank you. I appreciate the time that we have, and I look forward to questions both at this particular forum or other times over the next day or two. Certainly any of us with Air Products would welcome questions and interaction. And Mark, I think I will turn it back over.
Thank you so much, gentlemen. You know, one of the beauties of these type events, and certainly since I became involved in the hemp industry, is the interaction. And I know in our earlier discussions with Tim and Michael, I was fascinated by what they're doing. I know I mentioned in my opening comments that we have a test lab here, and it's funny because there still are, not funny, one of the problems remains is the differences between test lab results. And when we really started getting into this area, I thought most of the differences would be because of the equipment. You know, some folks can afford much higher levels of equipment than others. And hearing Tim and Mike talk about, you know, like the moisture content and the material preparation, what we found is that the equipment is not the reason for difference. It really is as simple as the initial sample preparation. The drying is a big deal, how it's dried and the content. People have a lot of ways. Until there are standards, we'll continue to see this. So again, guys, thanks for the presentation. I personally want to learn more about what you're doing because of the work we're doing down here. And with that, I'm going to turn to my new friend Dozie, and I think you're in for an interesting presentation. I also mentioned at the outset how the Institute is involved with the use of beneficial bacteria. And of course, Dozie's work involves fungi. And I think, and I know as we've talked, you know, most of agriculture until recently, we relied on chemical products, right? Pesticides, fertilizers. And the world is ready for some more natural approaches to things. So the work that Dozie is doing in his area is one of those ways we can use naturally occurring things to solve some agricultural problems. So with that, I'm going to turn it over to you, my friend, and I'll go back on mute, but be ready to assist in any way. And you need to unmute.
Thank you, Mark. All right. I appreciate the introduction. And with further ado, hi, everyone. I'm Dozie Mbonu. I'm the co-founder and CEO of Janerette's Eco-Friendly Fungi Incorporated, doing business as Dr. J's Fungi. And today, I am very excited here for the opportunity to present some of our recent findings from the past 3 years of dealing in the agricultural space, the hemp space, and the correlation between what the hemp industry is doing right now, especially with some of the groundbreaking and landmark voting that is taking place with the United Nations and with our House of Representatives in the past week. It just gives, the timing is perfect because, as I mentioned to Mark in our call, he and I's private call on Thursday, that from these recent trials in the last 3 years in agriculture and in the hemp industry, what we're finding from our results is that, and what we're seeing from our market research is that the hemp industry, especially for new technologies such as ours dealing with beneficial fungi, is the gateway to new technologies for the rest of the entire agriculture industry. So this is a very groundbreaking time period in our society where the hemp industry can be the leader in new technologies for the rest of the agriculture industry. And without further ado, I will share my screen here and present all about Dr. Janerette's Eco-Friendly Fungi and what we've been doing and what's to come. Thank you. Slides. Mark, will this take me when I put it on slideshow, or do I have to put it first? Excuse me. Hello, Mark. Hello.
Hi, this is Tim. I can say if you just put it on your slideshow down at the bottom of the page, it worked very fine for me.
Okay, let me put it on slideshow first. There we go. Is it showing as slide?
It is, yes.
Okay, thank you. I'll run through now. So as I mentioned, we are Janerette's Eco-Friendly Fungi LLC. doing business as Dr. J's Fungi. And fungi just makes the world better. I have been referred to as the fungi guy, who is also the fun guy as well. Here we have what is Janerette's Dr. J's Fungi Sustainably Solves Agriculture, Forestry, and Environmental Challenges. What we're looking at here is a picture of devastation due to a forest fire for a cannabis farm in California. This is one of the issues that Dr. J's Fungi, our beneficial fungi products, addresses in the environment. When you have situations such as these natural disasters, how can you bring this type of environment back to life and as soon as possible, so that Mother Nature helps us return and heal the earth in ways for recovery and for future sustainability? This is my aunt, Dr. Janerette, one of the world's leading, plant botanists with a concentration in plant physiology. She used to work for the US Department of Agriculture, where she first started looking at these beneficial fungi. They are technically called ectomycorrhizal fungi. And what she was able to do is create an inoculant. This was years later. She was able to create an inoculant that is non-GMO, organic soil additive that significantly increases plant yields of both woody and both non-woody plants, which until now is thought to be impossible, because when you're dealing with beneficial fungi, they say one typical type of fungi, which is referred to as the endo, only works with non-woody plants, and the ecto, which only they say works with woody plants. Well, what I'm going to show you here today is that we only work with the ecto, and what Dr. Janerette and the beauty of her work is that she was able to make a viable inoculants that serve both purposes through ectomycorrhizal fungi, but they also form endomycorrhizal fungi relationships with non-woody plants as well. She is a sustainability and environmental expert. I will highlight two of her career achievements back in the 80s, after she left from the Department of Agriculture because they shut down that headquartered laboratory. And she took her job as a consultant, and her first consulting job was she defined the terms for the Department of, for the Environmental Protection Agency. She actually wrote their decision tree for how they handle oil spills. Her next project contract as a consultant, she actually defined the terms for what is now the Department of Energy for how they handle radioactive materials. And then Dr. Janerette went into academia and brought her work with her, and that's where she started continuing to discover all these new benefits in beneficial fungi in botany. Excuse me here. Excuse me. Are we going backwards? Can I go back a few slides? There we go. Sorry. There we go. So here's what you have in the hemp industry. You have problems such as poor soils where the land has been overused, mineral deficiencies in plants due to some of the things that are utilized in cultivating cannabis, and happens to not be enough nutrients in the environment. So that's when chemicals come into play in the industry. You have here on the right a picture of pathogenic diseases attacking a hemp plant. And this is exactly that type of devastation that happens in the industry. Here's the simple solution. What you have here on the left at the top, that is a beneficial fungi. What happens is the beneficial fungi, when it connects with the root of the plant on the right, and what they have is this real special symbiotic relationship between the two gets formed. And what you end up here is this intricate root system at the bottom, which happens because the root, the plant, gives the fungi housing and energy in terms of sugar. And in return, the fungi, these beneficial fungi, dig deep into the ground, into the soils, and return beneficial nutrients, underground waterway, and it acts as a highway because what these fungi have are hairs similar to hairs on our bodies. And those hairs are what brings in all the extra nutrients, water. And what you have here with this technology is also that plants in their DNA are wired just to absorb only specific nutrients within a soil environment. They do not take in all of the nutrients within that environment. What our beneficial fungi do allow for plants is that they actually digest the other nutrients that plants normally will not absorb. And then they feed it to the plant in this symbiotic relationship, and therefore attributes to increases in the total growth and biomass of the plant. It ends up increasing the seeds. It increases the fruiting bodies. Everything increases within this plant environment. And we're not talking about marginal results. We're talking results in upwards of 40% or more increases in everything above board. This is what we're about to show you, because this can be applied. And here you have on the left a tree that isn't planted with our beneficial fungi compared to a tree that is planted with our beneficial fungi. And what you end up happening, what ends up happening is the growth rate even increases extremely rapidly compared to normal agricultural growth rates. And as you can see from the slide here, it applies to different sectors of the entire agriculture and forestry industries, dealing with farms, forestry, strip mines, nurseries, deserts, and prairies. These are our two first products as an early stage startup company, as we are about to head into our first initial manufacturing run. It's very exciting times. Synococcum geophyllum, which is referred to as CG, and Pythalysis tentactorus, which is referred to as PT, are our first two inoculants out of the gate on our manufacturing run, which begins here in January of the next year. So we're very excited as to where things are right now. Here you have, I included an agricultural slide of the work Dr. Janerette previously did in the laboratories and in her work, here you have an asparagus plant, actually. In the middle is a control plant, normal with regular fertilizers. And on the left, you have an asparagus plant planted with our CG. And on the right, you have an asparagus planted with our PT. If you notice the difference, this plant on the left is very tall, and that's what the CT initiates within the plant, a growth of extra height. And with the PT on the right side of the control, you will see it's more dense. And that's what the PT initiates. It initiates the density and the width of the plant to expand. And what we're going to see further here into our trials is that depending on your environment and your grow environment, whether it be outdoor, indoor, in applying it to the hemp industry, we can have an inoculant based upon the area, whether you're indoor and need to utilize a space more with height going upwards, then we would suggest the CG. Compared to if you were outdoors on a farm, we would suggest the PT to give you more room because you have more room in the outdoor environment. Here you also have already tested some of the work Dr. Janerette had previously done with asparagus, dwarf maize, soybeans, lima beans. And what you see here are the height, even with the asparagus increased at a rate of 149% increase, the stem diameter 27%, and the total dry weight. If we go down to things like the soybean, which is a very popular crop, you will see the height increase by 45%, the dry weight by 16, the number of fruiting bodies, pods, by 54%, and the number of seeds by 53%. Here we go to our first hemp trial in the new era in 2017. We were fortunate enough to be invited by the president of the Pennsylvania Hemp Industry Council, Miss Erica McBride, and she invited us to a trial for the Pennsylvania Department of Hemp in 2017 on an abandoned anthracite coal mine in Luzerne County. This is a phytoremediation project where we planted just with what Mother Nature provided and left it for once we planted and covered, Mother Nature just provided what she did and what you're seeing here. Even though the whole trial of 5 acres was not fully successful at all, this data here gave us a lot of things and opened up a Pandora's box for further research on phytoremediation. And what you are looking at here are the seedlings that came up through the anthracite coal. Then you had a vegged in the middle hemp plant. And what you're seeing here on the right, while it's dwarfed, is a hemp plant, industrial hemp plant ready to bud, but with no nutrient deficiencies whatsoever in this environment. And I will show you a close-up of what this really looks like. This was the 5 acres, and the lines with the pink lines are the plot that the Pennsylvania Hemp Industry Council, the Environmental Protection Agency, the Department of Natural Resources, Conservation and Natural Resources, Lehigh University was involved in the total trial. And this is how we planted that day. We opened up the ground with pickaxes, planted by hand. That's 1 tablespoon of our inoculant, the CG. For every tablespoon, we added 5 hemp seeds just to be sure for inoculation. The standard in normal agriculture environment and cultivation would be 1 teaspoon per seed, seedling, or clone per plant. It's a very sustainable application process. And once we left, here's what we ended up with. As you can see, this plant doesn't have any nutrient deficiencies whatsoever, is very healthy, and is ready to spring forward the beautiful biomass that you will see later from one of our normal hemp trials in a normal cultivating environment. So this here gives us a lot of room for further research to go forward, because as we all know what hemp can do in terms of bringing out toxins from environmentally challenged environments. And here we have, if you're able to grow healthy hemp in these environments, now that leads to further research for remediating brown sites. So the future looks bright with the research that we've commenced. Here you have a picture of our product being sent to a farm in Puerto Rico after the hurricanes in 2017. That was the farmer making his first plant on the soil with our product. And we were able to bring that farm back to life in a very quick amount of time. That is what our inoculant looks like. It is granular. As you see, the teaspoon is there to show the ratio of 1 teaspoon per plant, seedling, or clone. And what we also had some questions as to, well, what about regular farming equipment? And what we learned through our trials is that this product, which is granular and what you're looking at, also liquefies at a certain temperature, so it can also be applied to standard farming equipment. Here you have a trial, agriculture trial we performed in Kenya, and this is why I'm showing the correlation as hemp as a gateway for these type of new technologies for the entire rest of the agriculture industry. We did this trial in Kenya with CG, and we planted, this is what you're looking at is a fig tree. And we went from the seedlings from the left to the veg state on the second picture. And this is the grower who planted in Kenya. What you're looking at, the third picture, is when he transplanted, because of a lack of water being close to the edge, you're looking at what the standard root system of a, the standard root system of a fig tree planted with regular fertilizer compared to the last picture, what the root system looks like planted the same day after being inoculated with Dr. J's fungi.
Hey,
there is a picture of the root system. It goes all the way down to his knees, and he actually broke off the second side of the root system when he pulled up the root. And what's so remarkable about this trial is that one day he called me and he said, Dozie, something is going on here. And he said to me, from our market research, the entire fig tree industry, it takes 2 to 6 years to get to a ripe fruit from planting, the initial planting. This trial, what you're looking at, because of that enlarged root system, it produced healthy, ripe fruits in 12 months. And now this gives us a lot room to go much further in regular agriculture research. Here you have a tomato trial as well on that same farm. What you have here is a side-by-side comparison on the bottom two pictures, the left and the right, of planting the day with fertilizer versus Dr. J's fungi. Here you have the tomato plant that grew. Both plants were affected with an invasive species. They did use a pesticide in this trial to combat. I won't name the company where they used the pesticide. What took place and what you're seeing in the last two pictures are the result of Dr. J's fungi's plants recovering after 2 rounds of pesticide usage compared to all of the controls having to be destroyed due to lack of recovery after 3 rounds of pesticide usage. The third and the fourth picture. So I'll do this in a way. What you're seeing in the fourth picture is what took place at the harvest. And you will see the size of the stems, the size of the tomatoes really grew in the ways that we talked about earlier in the presentation. The middle slide, the third one, is what you're seeing is part of our groundbreaking results, because that is the plant 1 month before a second harvest. And as you see, the rest of the grow area has other tomato plants, but our plants hit the top of the grow house and started growing back towards the ground. And we achieved 2 harvests for this farmer. So not only did we save his original harvest, but we actually produced him a second harvest naturally in this environment.
Hey, Dozie.
Yes.
I'm afraid I'm going to have to play timekeeper.
Perfect.
So we have enough time for Samir.
Yes.
I know we've had one question come in, and I'm concerned of running out of time. So I don't know if you have a parting word, and then we'll got to stay on track. Sorry about that, sir.
No problem. This will be the finale here. Wild Fox Farms. This is the trial that gave us all the data to go forward with future hemp trials. We started here with regular planting in cedars. After a few days, we came to this. Then you saw the difference between our fungi versus the control. Then you had the 2 outsides versus the middle control. This is the type of growth rate through the transplanting. The plant number 6 and 5 are plants planted with Dr. J's fungi compared to plant 4. You will see the extra biomass. Then the root system on the bottom is Dr. J's fungi's root system that I talked about compared to the normal root system of the controls. This was the trial. This is the biomass, the evergreen color, the richness. We took it to the lab for data trials. What you will see here is that in each, this is the control in each trial data, all of the cannabinoid profiles and max THCs increase when Dr. J's fungi was applied. I will go back real quick. That's with the control without. This is with Dr. J's fungi. This is the control without with 10. This is with Dr. J's fungi. So we look forward to what's coming. Our competitive analysis doesn't give us any competitors who can achieve these same type of results in the hemp industry to date with extended shelf life, a sterile product. It works in sand, it works in poor soils, and does everything we said it does, increases growth with woody and non-woody plants. This is our business model going forward.
Hey, Dozie, I'm gonna have to step in because I have to have enough time left for our final.
Yes, and we're done.
So if we can,
and this is where we're at. and we're raising money, and we're actually in the middle, ending our raise fund. And would like to thank you for allowing us to present here. Thank you.
Well, thank you. Very informative. And as we discussed, these new approaches to solving ag problems are super important. I want to move right into Sairam, who's with Penn State Harrisburg. I will tell you that he has his fingers in a lot of research issues related to hemp. So I think you'll find his work fascinating. So I'm going to turn it right over to you, Sairam, to begin your presentation. Dozie, if you can unshare your screen.
Oh, sure. Thank you.
And we'll move on.
There we go. Thank you, everyone.
Thank you, sir.
All right.
Good morning. Can everybody see the presentation?
Yes, sir.
Okay, very good. Thank you. First, I would like to thank the organizers of the Hemp Summit, the Kelly and Gina for a wonderful job for organizing this conference, and the PA Department of Agriculture, the staff. In particular, we had a very good interactions with Kathy Thomas and Sarah Pickle as we were receiving these permits. So as Mark, thank you for the introduction. I'm a faculty member at Penn State Harrisburg, and I'm also the program chair of biology. So we offer a very nice biology program essentially at Penn State Harrisburg. Anyone is interested, we offer the 4-year program in genetics, developmental biology, and general biology. So if anybody is interested, please definitely contact me. We have exciting new biochemistry offerings as well. I also play a role as the director of this laboratory, Central PA Research and Teaching Laboratory for Biofuels, thanks to the Department of Community Economic Development. This was a public-private partnership where we were able to build this lab, and several hundreds of students have gone through the lab and received training. We started off our work, basically my experience, I'm a plant biologist, I'm a plant breeder, plant molecular biologist, and essentially we started off with the biofuels. I was working on cellulosic ethanol, biodiesel, miscanthus, switchgrass, sweet sorghum, and camelina, and several other crops. And then came along somewhere in 2017 when this opportunity was presented to us by the Ag Secretary, Russell Redding. I was very excited to participate in this hemp program. And essentially we started our research. We received our permit in 2018, towards the end of the November of 2017, started all our activities in 2018. And we were the only group who received a complete research permit to do genomics, proteomics, metabolomics, and any genetic modifications in the state at that point of time in 2000. This is my research team. Myself, I'm the director and PI of the lab. Dr. Shobha is a faculty member in the biology program. She's a co-director of this laboratory. And I have my lab manager, Hannah Whedon, and I have Dr. Deguchi and Dr. Vijay, who are the postdocs. Dr. Deguchi is a molecular biologist, expert in CRISPR gene editing. So what I'm going to present to you is, for researchers such as myself, challenges are opportunities, essentially. So what I will show you is what kind of research projects we are involved at Penn State Harrisburg in my research lab. One of the major things with industrial hemp has been to produce a lot of clones for farmers. Since the seed, there is a significant variability in the seed industry, and it takes a long time from seed to a seedling, and the seed germination resources are a lot. So to avoid that, one of the things that we have developed is a tissue culture system. I will talk about that. The other issue is the variable concentrations of THC because of the environmental stressors. And also some of the mixture with the feminized versus females versus the males in the seed lots. So there is no consistency, batch to batch consistency in either the seeds or the CBD and CBG. One has to go back and think hemp is not corn or soybean, not so much of research has been conducted. One of the other issues has been disease resistance. So some of these challenges we have turned into opportunities, and those are the things that we are working in my research lab. So the very first thing is we have developed a very nice system for industrial hemp clones. Almost we can get from 100 normal cuttings, can get about 70,000 clones, 100 tissue culture vials. In comparison, we can get 2 million annual clones. You can see the power of tissue culture. And one of the most important thing about tissue culture is you take a small explant and you can get hundreds and thousands of genetically identical clones. And these are disease-free and they can retain your high terpene profile and concentration. So everything starts with a mother plant, and from there you can make hundreds and thousands of plants. So this is a way to also, if you use meristem culture, you can just get virus-free plants, and we can maintain the feminized varieties. So this is something we have thoroughly optimized in my research lab, and we are taking towards the end of the presentation, I'll show you how we are taking this into the market in the commercialization area. The other very important thing everybody talks about is the cannabinoids. Everywhere you go to Sheets, you go to CVS, everywhere you see CBD, CBGs, and these are the products that are sold in the market, essentially. So how are these THCs and CBDs made in hemp? It's a metabolic pathway. So what we are very interested is in looking at this metabolic pathway and trying to avoid the psychoactive compounds THC, because for the feed industry in particular, having THC will never get a regulatory approval. So what we are trying to do is we are trying to look at this metabolic pathway and try to remove the THC. How can we do that? We have successfully done that in several other crops, removing a particular metabolite, but more so now with the new tools of genetic modification, not the GMO. This is a CRISPR gene editing where it is not considered as a GMO. We can use the gene editing technology to remove a thing. So what we basically do is we introduce the gene into we use the CRISPR technology to silence the gene, in our case, the THC. So we have been able to successfully demonstrate that. We use some of the knocking out vectors like THCs, we can knock out the THC pathway completely. So what we have done is, for a proof of concept, we have introduced a marker gene and tried to see if we can remove that. One kind of marker gene was phytoene desaturase. We can see that we can completely silence the gene, and we published this in the Nature Scientific Reports. The other technology that we are trying to develop now is RNAi spray technology. So essentially you can grow your hemp plants, and right before the 15-day window of the harvest, you can spray and silence the THC almost to a level of 0. So the farmer does not have to cut off the crop or anything, or lose because of increase in THC due to the environmental conditions. Other research projects that we have done, and very interesting work from my colleagues, Dozie, on the phytoremediation, we have tried to use industrial hemp plants to see if we can clean up the soils. We were fortunate to work with Bill and Martha. They provided us the abandoned mineland soil from the Newport area, and essentially we grew hemp plants. And what we were able to see is the certain compounds were extracted into the leaves, but not the floral tissue, which was very nice results. We also saw an increase in the cannabinoid contents as well as the THC content when the plants were grown on the abandoned mineland soil. The other thing that I mentioned during the challenges was about having the mix up between males and females. So we wanted to have completely feminized varieties. So we are trying to look at a molecular approach to see why does a female plant get converted into a male plant under stress conditions. So we looked at that, and what we found is you can have a female plant, you can have a male plant, or a mixture. And we saw that this particular gene ACS, which is a key regulator in the cellular respiration pathway, is upregulating. So as a part of evolutionary strategy, females, when they undergo stress, they simply convert into male and then they escape as a pollen grain. So that is the process. So we are looking at that. The other area that we are exploring now is Ayurvedic genomics, which is nutraceuticals. Nutraceuticals, there is a lot of new studies that are coming. We are looking at CBD, CBN, CBG, and CBC to fight cancer, anxiety, diabetes, and other conditions. So our preliminary studies with the College of Medicine was extremely promising, where we saw in acute leukemia cell lines almost a complete arrest of metastasis. This is a very potent cell line that almost cannot be treated with a pharmaceutical compounds even. So there is a good promising data with this. Now we are taking this into a private entity where I'm assisting a group to set up this operation. And this company is looking at 3 phases: producing genetically identical disease-free clones through tissue culture technology, developing nutraceuticals for anxiety and stress relief, and then the phase 3 will be genome editing to provide value-added genetics for the hemp seed industry. There are barely 1 or 2 varieties that have low THC. So this is the roadmap for the company, and the company is in the process of raising a Series A financing, essentially. And I've included, I know that these presentations will be posted there. I want to leave certain time for the questions. So there are some good advantages working together. The other thing that we are doing is we have taken that entire pathway of CBD and THC, and we are trying to introduce that into model crops. And this is any questions related to the company. I'm only helping them set things up, but David Kane is the point of contact. And once again, I absolutely sincerely want to thank the Secretary of Agriculture, Russell Redding. Literally, my career took a great turn moving into this industrial hemp area, and thanks to the Secretary's for his vision to advance industrial hemp in the state of Pennsylvania. And I would like to thank Mr. Tom Trite, PA Options for Wellness, Bill and Martha, and all the staff at the Department of Agriculture. Thank you. I'm happy to answer any questions.
Sairam, well done. Thank you for that work. And as he alluded to, for everyone in attendance, I believe most of the presentations that you see at this summit will be posted. And so if any of the group from this session is interested, look for those. I hate to let you know that we have run out of time, and I'm trying to stick as closely as possible to the timetable to not throw off the larger picture. So if you have questions, I would ask you to reach out to each of us panelists individually, and we can share any responses to the group. We'll work that out with the staff at the Hemp Summit. I would like to thank certainly all the panelists for your involvement. It's been great getting to know each of you, and I think that we will have some continued discussions between us because of some of the common interests we have. I would ask everyone that attended to virtually give our speakers a round of applause. Before we leave, I would like to take a moment to recognize our top level partners for this year's Pennsylvania Hemp Summit, which include Lancaster Farming, King's Agri-Seeds, Pennsylvania Agriculture Business Development Center, and of course, Air Products, Tim and Michael and their company. And I also want to note there will be surveys of each of these sessions that we would hope you would consider filling out. Of course, networking is a key feature of the summit. So please network virtually by using chat, and you can use the options provided through the website to look at people's files and forums and whatnot. So again, I would just like to thank all the participants as well as the panelists for your involvement today. I do apologize we ran short on questions. Thank you so much for everyone's participation.